computer. So welcome everybody to our CCNA 3 class for this week. I appreciate y'all being here. Hope you had a good week last week. Mine was good up until about 2 o'clock Thursday morning or 1 o'clock Thursday morning when I started throwing up, and I ended up having to go home from the NCCIA conference. I got up Thursday and drove home from the conference because I was running a fever and sick on my stomach, so I did not stick around to try to spread that to anybody. But we had a good conference. A lot of people got their CCST. We ended up with 57 CCST certifications passed, which was really neat. That's an excellent thing. So we were tickled to be able to get that done. We are going to do a couple things today. To start with, I want to just do a quick review of access control lists and what they are. Can anybody tell me what they remember about access control lists overall? Ben, give me one item.
Execute from top down, stop when they get a match.
Top down. And then they first ACE, we call them access control entries, that applies is used on the packet. Okay, what else, Kim?
There are several different types, named lists and the regular basic lists. The regular basic lists are very simple, and you want them as close as possible to destination so that you're not limiting the traffic that should be going through. And the more advanced named lists, you want closer to the source so that you can have the most control over it.
Okay, now you got a little bit of confusion there. There's standard numbered ACLs and standard numbered IP ACLs, but there's also standard named ACLs, and they're still the same. Standard ACLs filter by source, okay? But then we do have extended numbered ACL, IP ACLs.
Sorry, then I thought it was named were the extended ones.
No, you can have a standard named. You can have a standard named also.
Okay, well, extended ones that have more criteria that you can use, and you want them closer to the source.
Correct. So filter by source, and with the standard goes as close to destination as possible. Extended ACLs filter by source, dest, protocol, port, and these go as close to the source as possible.
You can have as many as you want, but you can only have one active per port per direction at one time.
Per protocol, correct. So you can have one per port, per protocol, per direction. Okay. I want to jump back up here real quick too. Remember, top down, sequential. So there's sequential. Top down, they are simply permit and deny statements. Okay. What do they end with? End with an implicit what?
Deny.
Deny, exactly. So everything that is not allowed will be denied. So you never want to write an access list that is all deny statements, because then you will deny, well, unless you want to deny all traffic, then you will deny all traffic.
That includes you, so you can lock yourself out with a poorly written access list.
In a hurry, in a very quick hurry, yes. So be aware of that. That is an important concept to be aware of. And I mentioned last week the idea of the reload command. So you can do a reload and then have it reload in 5 minutes. That way, if you do lock yourself out, you at least can reload and not have to drive 45 minutes to go to a city where you locked yourself out of it. Or ask someone to go in there and turn the router off and on, as long as you don't save the config before then. The other thing I like to mention here is a lot of people forget that to create an ACL, you must first, one, create the ACL, typically in global config mode. And then two, you have to apply the ACL to an interface in interface config mode. So you can create ACLs all day long, but if you don't apply them, they have no effect. They will not be used at all. So Remember too that ACLs are used for everything throughout the Cisco iOS, and we'll learn more about that as we continue on and learn, go deeper into our knowledge here. So here we can see this is a named ACL or a numbered ACL access list 10 with a remark statement which says an access control entry that permits only the host 192.168.10.10 to the internet. And then you do access list 10 permit host 192.168.10.10. And remember, host is just a replacement for 0000. So instead of writing out 192.168.10.10 0000, which means match all bits, you put host 192.168.10.10, and then it's created. But that's all well and good, but until you apply it to an interface, it's doing absolutely nothing. So you're gonna have to apply this access list 10 somewhere to the to an interface. And here's an example here. They're permitting only that host to go, and then they're going in and they're creating LAN 2 should also be permitted to go to the internet. And so they're putting the LAN 2 statement in to allow it to get in 20.0 here. You'll notice they did 20.0.000.255, which says anything beginning with 192.168.20 permit, and that would have been added to that, the second line. And it's also very important to realize when you create an access control list, when you add new lines to it, unless you change the sequence numbers, they go in as the next line in sequence. So if you need to change the order of an access control list that you're not using sequence numbers on, which is with our named ACLs, then you need to really take it out, put it into a WordPad, redo it, and then put it back in. So that's why many times we create our ACLs in Notepad and we save them in Notepad so we can reuse them. Then they went and they put it as an access group out. Okay.
And it's aggravating to me, they made access list and access group as different terms. So
Yep.
the ACC shortcut will work for both of them though. So that's what I got in the habit of doing.
Yeah, it will. You can tab them out and it'll shortcut it. But yeah, the IP ACC will work for both. And that is because on the interface, there's no other command that begins with IP ACC. So that's why you can use it. But you do need to know access group because it will show up on the exam when you start to go take your exam. Once it's applied, then it starts taking effect. Now, at this point, all traffic leaving this particular router will be put through that access control list 10. And you'll notice we put it as close to the destination as we could. But that's as close as we could get it. Because we couldn't do that, we couldn't get out on the internet because we don't control those other routers out there on the internet. Okay. Now, standard ACLs named go from 1 to 99. Numbered ACLs go from 100 to 199, and then there's another group that's up in the upper layers. I don't really, most people don't need to remember those, but the numbers are like 1,000 to let's see here, 1,000 or 1,300 to 1999 for standard. And then I can't off the top of my head remember the extended. We'll look at it in just a second. Once we've applied these, the other thing we can do instead of using just a numbered ACL, we can have a named standard ACL. So remember, numbered and named are just two of the same of a type of ACL. So they're standard and extended, and either one can be numbered or named. Here we have a named standard ACL. So we got rid of the access list 10, just got rid of it, and we renamed it permit access. So IP access list standard, and that's how it knows it's standard, permit access. And you'll see we've got a new sub configuration mode we've never seen before. Config standard NACL. So it's the standard named access control list sub configuration mode. Put our remark in, put our permit in, and put same two remarks and statements that we had before, and then we just apply it to the interface. Super important. It is very much case sensitive. So if this is all caps, this must be all caps. If you do not make them match, it will not apply the IP access list to the interface. And they would think they're two separate access lists. Okay. Show access list is a great command because it does show you all your access lists. It will also show you if you've got the log statement on what entries have been matched. So if you're trying to find is it actually being used at all, If you use the log command on one of these ACEs, it will then keep up with the number of times that particular entry has been hit. Okay.
Also to mention here, if you misspell the name when doing the access group command, it does not complain. So
Exactly.
that means you can think you applied it, but it not applied, and that's why all your traffic is going through.
Yep, that is exactly correct. Yep, it does not bark at you at all. It assumes you know what you're doing. And it's so easy to fat finger those names. You know, you may put in PMIT instead of permit. I've done that before. Put in PEMIT-access instead of permit access. And like you said, Ben, it will not bark at you. It'll just let you do it.
Also, practically speaking, leave yourself some space between the line numbers. If you go ahead and number everything consecutive, you can't go ahead and add anything in later when you need to tweak it.
Right. And if you do named, it's automatically going to give you 10 spaces. It's going to give you 1 through 9 in between. So you got 11 through 19, which is pretty good. If you need to add 9 spaces in there, that's a bit. But you can come back in here now and you could actually put a new statement in as statement number 11, which is nice.
I learned that way back in basic days.
Yeah. Yeah, exactly. You're exactly right. Now, ways to modify ACLs. One of the ways that we use, especially with numbered ACLs, is just a text editor. So you have to copy the ACL out, make your changes, remove the ACL completely from the router, and then put the ACL back on. All right. If, however, you're using named ACLs, you can use sequence numbers. So you can go in here, and since you've got a 10 and a 20, you could put something in. You can actually do no 10 and then put in 10 and change 10. Or you could put in 11 and put another permit or a deny statement. And again, remember, most of the time, deny statements come first, then permits. Not always, but most of the time. We want to deny first, then permit.
Hey, Kelly.
Yes.
Back in the day, it didn't matter as much, but today it's an absolute shark pit on the internet. You don't really want to leave an interface uncovered without your ACLs on. It would be better to go ahead and make a new ACL or to edit the existing ACL and then, you know, remove it and then put the new version on.
I would shut the interface down, make my changes, then bring the interface back up.
Okay.
That way, there's absolutely no way anything's going to get through that interface while I'm trying to make my changes.
Thank
you. Yep, I just shut it down, make my changes, bring it back up. That's really the only way to be secure, fully secure. Otherwise, you could have that millisecond where stuff could get through. So here we have, again, modifying a named ACL. Here they are putting in a line 15. And it will go inside. Okay. You're going to expect that. It actually, this makes you think that something is wrong. But what actually is happening is when you put these numbers in, the iOS now tries to figure out the best way of writing the ACL for you. And so it will actually look at the ACL and go, we think it's better to deny host 10.5 first, then do 10.10. And what it's really assuming is it's assuming that with 10.10, it's a bigger number that it would have either permitted or denied the 5, so it put the 15 before. So be aware, sometimes you'll make some entries and you are thinking it's going to be in one place, but the iOS tries to make something different. And it tries its best to always create an ACL that is the most efficient for you. Now, show access list will show your statistics. Okay. It'll show you how many times that particular access list has been hit, which is a good thing, because if it's not being hit, then you know it's not being used. And one of our most common uses for a very simple standard ACL is to control access to our VTY line ports. So by default, you can, well, it used to be you could telnet into any VTY line. What has happened now, if you've looked recently, you'll look at a router in the latest iOS on the line VTY, it has a command called transport input none. Okay. And that means that you cannot telnet, you cannot SSH into the VTY line. So there's no transport mode used to get into the V2I line. If you don't change that, you can't telnet and you can't SSH. So when we set up SSH, we put in transport input SSH. But we still want more security than just SSH. We only want to allow hosts on our management network to be able to go into the V2I lines. So we do that with a standard ACL in the access class command. So we create a standard ACL that will identify the management network or a management host. It could be a single host. Not typically a good idea to only use a single host to be able to access them remotely. I would use 1 or 2 hosts or a management network. That way, if for some reason that host is knocked offline, you've still got a way to get into your devices. But you create the ACL and then you apply it to the config line or the V2I line using an access class command number, and it's always going to be in. Don't even worry about the out. Well, there's no real outbound communication from the V2I lines. So here is an example of a standard named ACL, and we say username admin secret class IP access standard admin host, permit one host 1010, deny everybody else. Now, of course, they didn't need this, but they put that in there so they could see it. And many people actually do put that at the end of their access control list. They'll put in to deny all or deny any so that they understand it is actually blocking everything from a logical standpoint. They then went into the V2I line and like idiots set up a telnet. So I would never in the real world turn on telnet. It is completely open, so don't do that. But then they put in access class admin host in. And so what it's going to say is only 192.168.10.10 can telnet into the V2I line on R1. Now, we obviously would do transport input SSH and use the exact same command. Access class admin host in, and that would only allow 192.168.10.10 to be able to do SSH into R1. Be careful real world about setting this to a single host. I would have a management network or a set of management hosts that are in this V2I line access list. This is one of the things that's on the CCNA exam blueprint, and it says be able to configure V2I line security using an access list and access class. So make sure you know how to do this. It's not that hard, but it is one thing that you can do to make life a whole lot easier for yourself and to make your network a whole lot more secure. Questions about that? So now we've already seen a couple uses. One use for just, filtering IP addresses or IP packets going across the router. Now we've got another use already for controlling access to your V2I line, and they will continue. When we get to NAT in the next chapter, you're going to see an entire new use for ACLs as a NAT ACL. So let's look at extended ACLs. We have numbered extended and named extended. Numbered by default are 1 to 199 or 2000 to 2699. Most of the time, you only need to know the first range of numbers here. But if you really want to impress folks, go ahead and remember the second numbers. It is, you will notice, much more complicated. Access list, number or name, permit, deny, protocol, source wildcard, destination wildcard, port, established, that's if you're using TCP established, and then log. All of these different items are available. We may not use them all, but they are available. And this is where you've got to know what particular applications run on what protocols. Everything runs on IP, but does DNS run on UDP or TCP? The actual answer is both. It runs on both. Okay. How about web, www?
80 and 443.
80 and 443 TCP, correct, Ben?
Yep.
Ben, yep, TCP.
Yep.
So you gotta know those, because if you're writing ACLs for them, you've got to know what those ports are. Now, the good news is in the real world, when you're sitting there starting to write a new ACL, you can just do a question mark and it will tell you. But on the test world, we don't have that option. By the way, there is a new version of Packet Tracer that has come out, if you're not aware of it. It is Packet Tracer. Pull this over so y'all.
822.
822.
Yeah, on the exam, they don't let you have a question mark. They want you to know it.
Yeah. Well, they used to when you had the simulations, you could do the question mark, but the problem was you would not be able to pass the test if you had to use the question mark much. And real world, question marks are our friend by far, but let's jump in here, and I would have done a NetLabs reservation, but it just takes so much longer for it to boot. Come on. All right. So config T, just give it a name so we can talk about it. And then we're going to go IP access list 100. You see here. Oh, wait a minute. No, just access list. Access list 100. Permit. And it's going to say you can do protocols. You can start out with protocols. We're going to say permit TCP. We're going to do our source and destination. So let's just make up a source 192.168.12.0, the network 12.0. Anybody, EQ, and you'll notice in here, it's only got a couple. It's only got FTP, POP3, Telnet, and www. Real world, there are many more protocols that show up there. Okay. So if you put www here, that means permit 192.168.12.0 to anybody using TCP and using port 80. Of course, 443 would be secure HTTPS, et cetera, et cetera. So be aware of that. So you can put 443 here, but it doesn't show you the listing on Packet Tracer, as it will on the iOS. But be aware, an extended ACL is much more precise. It's more like a rifle shot than a shotgun. We're not just getting in the ballpark. We're going to have exact statements of what we want to permit or deny. Still has to be applied. No different than a standard ACL. Okay. Now notice here's the keywords here on the ports. Here's the real iOS. So permit TCP any. Here's just some of the different items that are on a real iOS: BGP, domain, FTP, and FTP data. Because remember 20 and 21 for FTP, unless you're using what is it called? Transversal FTP, or the FTP that is doesn't need both. All of these are on a real router. As you work on these, okay, again, protocol options, you got all kind of protocols. That's the first item here. And then all the different port options. You can be very specific. Access list permit TCP from any source to any destination using the web, or equal 80. Both of those mean the exact same thing and would do the same thing. What does access list permit TCP any equal 22? What does that allow?
SSH.
That is SSH. And then, as I mentioned, 443 is HTTPS. So you need to learn these because you're going to need to know how to apply them. Now, extended ACLs go as close to the source as possible. So let's look at this example. We got an ACL that permits both HTTP and HTTPS traffic from 192.168.10 network to go to any destination. So we're going to go in here and say access list 110 permit TCP from 10.0 any equal www and 10.0 any equal 443. And then we'll put it on gig 000 as an inbound access list. When you're trying to do packet tracers or you're on the test, do exactly what it asks for because it's very specific. Yes, I know that is only allowing www and 443, but that is what it is saying it wants. It wants those two types of traffic to go to any other network from 192.168.10.0. So you put it on gig 000. If you accidentally put it on as outbound on S010, what would you do? if you put this 110 ACL as an outbound on S101 or S010. You would still meet the requirement for the 10 network, because the 10 network would still be able to get www and 443. Well, what would happen to LAN 2?
Yeah, you'd block the other LAN. So.
Yeah, you block the other LAN with the implicit denial at the bottom of this access list. That's why placement is so important and knowing where to place it. Okay. Now, there's also, especially when you're building a, you can use even these simple ACLs to build a very simple stateful firewall. And this is called the established keyword. And so what we do is we set up an access control list that says access list 120 permit TCP from anybody going into 10.0 established. In other words, this is permit 120, so it's coming back in from the internet. And so we're allowing all of our LAN traffic to go out to the internet. But we want some way to control the traffic coming back in and only allow traffic back in if it first started inside our network. The established keyword lets you do that. Basically what this says is anybody outside can get back in if it has an established TCP connection with an internal host. So we created two ACLs here. We created an outbound ACL that says that LAN 1 can go somewhere, which would have been our 110. See here? 110, we're permitting www and 443 as an inbound on gig 000. And then as an outbound on gig 000, we put this 120, and that says only allow stuff back in if it began inside. So that is we actually just created a very simple stateful firewall with the router when you do this. Does that make sense? Okay.
Yep, but you need your DNS server on the connected to S1.
Yeah, you're gonna have to have some way for DNS to work. You're gonna have to have some way. Yeah, there's a lot of problems with this network, but it's an example network. I agree with you. Inside private network being would have to have DNS on the inside. You'd have to have some way to get back to the inside host. So plus, of course, these numbers wouldn't work anyway on the internet. So you're gonna have to have NAT going on here somewhere. So, and we'll talk about that in the next chapter. So named extended ACLs, you just put IP access list extended, give it a name, and then it works just like a standard extended ACL. So IP access list extended SERPing, remark permits HTTP and HTTPS. So this is that same 110 ACL written as a named ACL. Permit TCP 192.168.10.0 to anybody equal 80 and equal 443. You'll notice here again, we've got a different subconfiguration mode we've never seen before. It's config extended NACL subconfiguration mode. And then we got a browsing one here. This is that returning traffic. This is the 120 access list from above being rewritten as a named ACL. IP access list extended browsing, remark only permit returning traffic, permit TCP anybody going to 10.0 from to 10.0 if it's established. Then you do the surfing in and the browsing out. Apply it, and you would have your little basic filtering firewall here. Now, if you wanted to edit these, you could use your statements, your sequential statements. So you could do no 10 and then put 10 back in. Or you could add items in between, just like you can with the named ACLs with IP standard ACLs. I'm not going to spend a whole lot of time on this example. It's just another example where they're permitting FTP, SSH, Telnet, DNS, and then, of course, web traffic and secure web traffic. They're basically opening up more items for it to allow to go out to the internet. Show IP interface will tell you if there is an ACL on the interface. So if you need to know whether or not you have applied it, go show IP interface. Also check to make sure it's named correctly in the correct capitalization. Show access list will show you all of your configs or all of your access lists. And then honestly, I don't gripe at students if they use show running config. Most of the time, show running config is not a troubleshooting command. But with access control list, that's the one place I can give them a little bit of a slack because guess what? If you do show running config, you're going to see what ACLs are created and you're going to see which ones are applied all in the same running config. Now, of course, here they did begin IP access list and that got them down to that portion, but you also could just do a show running config, look at your interfaces, look at your ACLs. So I don't give students a super hard time if they happen to use show running config when we're trying to troubleshoot ACLs. I do think show access list is where they should start to see if the access list is even created and then try to figure out whether or not it's on an interface. But this is one of the few times I don't bark at students. By the way, if I'm interviewing someone for a job and their first command to try to do troubleshooting is show running config, that's a big red flag for me, unless it's something like this. Because there are times when show running config makes the most sense, but not often. All right. Now, folks, that's ACLs. Are there any questions on ACLs for me? Let's jump over to NAT then. Let's talk a little bit about NAT and what NAT has going for it. So, network address translation is taking our RFC 1918 address space. And by the way, the RFC 1918 is the private address space that was defined by IETF. And it is 10.0.0/8, 172.16.0.0, to 172.31.255.255, and 192.168.0.0 to 192.168.255.255. All of these are blocked by an ACL at every ISP router most of the time. Okay, I say most of the time because there are places in the world to where ISPs, there's so many people inside the ISP. The ISP actually uses private addresses inside of their ISP network, and they NAT themselves before they go to other ISPs. In fact, there's some places in India to where for traffic to get to an actual public IP address, it is NATed 6 or 7 different times just to get to a public IP address. Because there's so much traffic and so many computers. For us, typically we're not NATed that many times, maybe NATed once or twice, but we have inside most of our homes the range 192.168.0.0 or 192.168.1.0 unless you've changed it. So that's the most common with Linksys and other home routers. Your internal address space is being NATed to some actual public IP address. So a real public address. Why do we need it? Well, first off, all of us are running RFC 1918 addresses inside of our networks. We're out of IPv4 public addresses and have been since about 1999. So we don't have any more. So without a NAT and its abilities, we would have been using IPv6 a long time ago. Okay. So here's an example of what we call a stub network, only one exit point to the internet. That's what most of our, I bet almost all of our home networks only have one exit point to the internet. And that's just a fact because we don't have multiple connections to multiple ISPs. It can happen. I've actually seen people with home networks that do it, but it's very rare. So if anybody on this stub network wants to get out to the real internet, they've got to get themselves a public address. So I like to talk about inside and outside. Now I know there's inside public, inside private, or inside global, inside local. Yes, you're going to learn that too. We're going to talk about that. But for most students, if you just get them to understand the difference of inside private addresses being NATed to outside public addresses. Yes, Kim.
Do you have any really good way of remembering between those? Because they'll talk about it by name. And like, I know the theory behind it, but when they ask a question on the test and talk about inside global, my mind immediately blanks on which type they're talking about. Do you have a memorization?
I don't have a
into that?
memorization thing on it. No, I don't, honestly. And I'm sorry, but I just don't. Let's get to that section. I'll talk a little bit about it, but we'll try to figure out a way to think
If
about
anybody
it.
else does, feel free to PM me later.
Yeah, I mean, right here it is. the inside local address is your private address. Okay, so the inside local is your private address. The inside global is the address you're being NATed to. So inside local to inside global. So they're both inside. Now, outside local and outside global, 99% of the time are going to be the same. Okay. The only time those are different is if you're actually NATing between two of, the only reason this even exists at all is if you happen to be NATing between two networks that both use the same private address space. Because what happened then, Kim, is you're going to have to actually NAT both ways. You're going to have to NAT the inside local and the outside local. So the outside global will be different than the outside local. All right. But inside local, that is your local public address. Okay. I just thought of something that might work for us. Okay. You ready? Inside local, obviously, is our local address. It's our private address. Inside global is the public address you're going to be NATed to. So think of global as going to be NATed. So inside local is our local RFC 1918 address. Inside global is the public address we're going to be NATed to. Now, anybody that watches this on the internet, save the flame mail. I know an inside global address could be a private address. All right. I'm just trying to help people figure out a way to think about this. Okay. It's the address you're going to be NATed to. And again, Kim, the reason I say that is if you had a 10 network here and a 10 network here, and you're going to NAT between the two of them, you're going to have to change both sides. And that's where all this really comes from. Inside though, those addresses are your public going to private. Typically your outside addresses are already public addresses that they're just the public address when it's inside, our local device and our local network, or it's outside in the global. Okay. So outside local is the global address internally before NAT. Outside global is the global address external after being NATed. And it's typically the same. You notice it doesn't change here. But our inside local gets NATed to an inside global.
Yeah, I heard that, but that last part still is not helping me to remember. I guess I'll just have to get through it.
Well, again, inside local is your local public address. Inside
that
global,
part, it's the whole global, local, and
okay, but inside global then is the address that you're going to be NATed to. So it's on the other side of the NAT device once it's been NATed. Inside local is inside your private address. Inside global is the address you're going to be NATed to. That's all I got. That's the best my English degree can come up with for a way to remember it. The good news is outside local, outside global, they're just the same address, and it's just depending on where you're looking at. If you're looking on the inside of the network before it's NATed or outside after everything's NATed. Same address, same 99.9% of the time it's the same address. And I say that because when you go to if you get deep into CCNP and some weird stuff with NAT, you can do some crazy stuff. But just be aware of the way we look at it. Honestly, inside, outside. The inside is the private address, outside is the global address. That's how I remember it, even though I know we've got all these crazy numbers. So inside local, the address as seen from inside the network, typically a private IPv4 address. Inside global is the IP source outside the network, which is what you've been NATed to. Outside local is the IP address as seen from inside the network, and outside global is from outside the network. So you'll see here again, the PC inside is 192.168.10.10, but it's being NATed to 226. Outside, it's going to the same address with 209.165.2011. Either way. And the whole reason we have all this is because the fact that you could possibly have two publicly addressed networks with the same range of addresses together. Good news is this stuff's very simple to set up. Static NAT, 1-to-1. You got one public, one private. So the inside local address is 192.168.10.10. The inside global is some static IP address that you set. This is typically for our servers that need to be accessible from the internet or on the internet. Dynamic NAT is when you take a pool of addresses and the pool of addresses pulls from all those numbers in the pool until it runs out. And then typically what happens is on the very last address in the pool, it will actually do overload. And you can tell it to do overload. It doesn't always do that by default, but you can set it up to do overload on the final address that's in the pool.
Yeah, if I remember, PAT really isn't that much worse than setting up DHCP.
No. And then PAT is the same thing as a pool being overloaded, but it is overloading to an already assigned IP address on an interface. So you're just sharing the outside address. Now, I'm going to tell you how I look at this. And I actually, when I wrote a book for Cengage years ago about CCNA, and I fought with my co-authors about this. But this is how I show and what I talk about with NAT. You've got static NAT. All right. Static NAT is a 1-to-1 mapping. Okay. So one internal RFC 1918 to one public. You then have what are called, we saw it here. Our next item was our dynamic NAT. Okay. So we have dynamic NAT. Okay. And this is 1-to-1 mapping, but from a pool. From a pool. Okay. Now, if you set this up like it's shown right here, what would happen if 192.168.10.12 took 226, 10.10 took 227, 10.11 took 228, 10.13 took 229, 10.14 took 230, and 10.15 then tried to get out? So all of these, it says they're available, but let's imagine they're all mapped to 10 through 15 here. So 12, 13, 14, 15, and 11. What would happen to the next IP address that tried to be NATed from this pool?
Seems like it would be blocked.
It would be blocked. Yeah, it would be, exactly, Ben. It's going to be blocked. There are no more addresses in the pool to give out. It's used up. Okay. That is dynamic NAT with a pool. There's another thing you can do, though, that a lot of people don't think, that they don't talk and don't put in the curriculum anymore, but it's dynamic NAT with overload. Okay. So it's still a 1-to-1 mapping from a pool, but overloads when there is a single IP left in the pool. So in other words, all of these 10-12 would get 226, 10-10 would get 227, 10-11 would get 228, 10-13 would get 229. Then everybody else would be overloaded with PAT using 230. So it'd be everybody else. And by the way, they say that a single IP address can support about 4 million sessions. So that's not 4 million hosts, that's 4 million sessions. Just like right now, my PC's got a session to WebEx, it's got, not WebEx, a session to Zoom, it's got sessions to my email, it's got sessions to Netacad, 4 million sessions per public IP address. So that would be NAT, dynamic NAT with overload. And then finally, our last thing is PAT, which is port address translation. And this is a overloading port address translation to an IP already on an interface. Okay. So you've already got an IP address, a public IP address on the interface. You're just going to share that with all your internal hosts. That's what we're doing in our home networks. We've all got a public IP address out on our home router, and that IP address is being shared by everyone inside our home network. That is PAT. And that's probably the most common form we have today is PAT. Okay. So here's an example of PAT. You'll notice source inside local is 1010. Notice how PAT has to keep up with port addresses. That's why it's called port addressing, because it uses those ports to share the same IP address among multiple hosts. They both got 200.226, but 10 is using 1555 and 11 is using 1331. And that's how it can keep up with the conversations going in and out. If by chance, which can happen, if 1010 and 1011 had picked the same internal port number, NAT would have just incremented it by 1 when it did the translation. So as long as it's in the table, it doesn't matter. So if for some reason 1010 and 1011 both randomly picked 1555 for their port number, it would have been mapped to 1555 and 1556 or whatever open port number that was available. Because as long as the NAT can keep up with who's mapped to what, it doesn't really matter what the port numbers are. So that's how it deals with random port numbers and the possibility of them being the same when two IP addresses come in.
I wonder if that's actually accurate or just for display, because I thought it always changed the port number at the NAT, or maybe that's with
I
other
don't think it
devices.
does. Now, I will tell you this. Now,
Because I thought it always went above 42,000 or something for some reason.
yeah, well, yeah. Now the numbers themselves here these may not be accurate. These are just
Yeah, but like I said, I thought every time it changed the changed the source port, but
well, Ben. It may be this. It may be you're thinking about NAT through something like a Palo Alto firewall or a PIX firewall. So
well, just for like a little home router is what I thought it did.
yeah, and it may be. Maybe that's how they're set up. I don't know. I hadn't looked here recently.
But maybe on the Cisco ones it does different.
Well, I know that on some of the high-end router or high-end firewalls, it will actually change it for security reasons. To give an extra layer of even more anonymity on the inside networks setup. That'd be interesting to look at when you do the real lab. Take a peek at it and do a show IP NAT trans and see what it does with the real gear.
And we'll do that.
Yeah, that'd be good to bring back to us. By the way, if there's no port available to just use next available port, here's an example it's showing where they're both using 1444 and another tries to use 1444 and it just increments it by 1. So, it's not that, it's exactly what it's going to do. Long as the NAT table can keep up with who's who, it doesn't matter. So NAT is more of a one-to-one mapping, whereas PAT is a one to a global address that's on the outside interface. NAT uses, if you're not using NAT with overload, uses only IPv4 addresses in the process, whereas PAT does use the TCP, UDP port numbers. NAT with overload does that too, but they've kind of done away with NAT with overload as an explanation. And then for NAT, a unique global IP address is required for each inside host, whereas a single unique host unique global address can be shared among many hosts. That 4 million session number is a good session to remember for the real world, because in the real world, you've got to kind of balance what you've got, depending on how big your networks are. Okay. Now, advantages of NAT, obviously, we don't have to run IPv6. That's one big thing. It conserves our IPv4 network numbers. It increases flexibility of our internal networks because we can all use whatever the public addresses we want. Typically, we're all running 10s just because it's big and we can use it. The negative is it hides end-to-end connectivity. So you don't have the ability to easily track all the way back every single time to a source. And so that's a big thing. That's one of the reasons why IPv6 doesn't like NAT and doesn't want to do NAT, because they want you to be able to track all the way to the source of a packet. I'm going to quickly blow through these next couple sections because I want you to realize next week, folks, I will not be having class next week on Wednesday. I will be at Adepticon in Chicago. So we will not have class next Wednesday. So you need to keep working on our class items, but I will be checking email a little bit. I'm actually on full PTO, taking personal leave. But of course, like I told somebody, there's no chance I really will ignore my email totally. But we will not have class next week. But here's an easy static NAT, IP NAT, inside source static, inside outside. That's how I remember it. IP NAT, inside source static, inside outside. So you put the inside private address, put the outside public address, and that is all you have to do other than set what is your inside interfaces and what is your outside interfaces. So NAT is a two-step process. Static NAT, configure the static NAT, and then configure inside outside. If you forget to do this, the second part, it won't use your mapping. And if you do it backwards, it won't be able to use the mapping correctly. If you want to look at static NAT, do show IP NAT trans, and it will show you your translation. And you'll see the inside local, which is your private address, being translated to a public address. You notice there are no port numbers here because this is, at this point, a one-to-one translation with no traffic going through. As soon as that traffic starts going through, then you start seeing where the connections are to other hosts. So this is an example of 192.168.10.254 going out through 2015 and connecting to a host 209.165.200.254. Show IP NAT statistics shows you inside and outside interfaces. Also shows you the active translation, static and dynamic. I like show IP NAT trans. I don't use this as much, but it is a good way to see your interfaces. Show IP NAT statistics. Okay. Dynamic NAT, we're going to create us a pool. So we're going to go in and create a pool. All right. So we create our pool, IP NAT pool 1, that's the name. Then we're going to do start address, end address, and whatever mask we're going to use. We then will go in and create what's called a NAT ACL. Now, this is a standard ACL that says what can be NATed. So this ACL says if it matches this statement, it begins with 192.168.0.0, it will match this access list. And then that access list is actually applied to the NAT. So IP NAT inside source list 1, use pool NAT pool 1. So basically this command here says, we're going to NAT anything that matches ACL 1 using the pool we created called NAT pool 1. So if it's a number between 192.168.0.0 to 192.168.255.255, we're going to map it to these numbers in this pool right here. Okay. Once that's done, you still have to set inside and outside. Okay, that's some can't get away from that. Got to set your inside and outside. When that starts happening, those inside local addresses will start grabbing addresses from the pool. When the pool is expended, no one else can get an address until one of the other addresses times out of the pool. Or you do a clear IP NAT trans, which will actually clear the translations. Now, there's another thing you can do here. If you change one statement on what we did above, if you literally change this command right here to IP NAT inside source list 1, pool NAT pool 1, overload. So just put the word overload after this NAT pool. It will then map 1-to-1 for every address till it gets to the final address in the NAT pool, and then it will do pat on that one address. And it's really just dynamic NAT with overload. Okay. But that's what will happen if you happen to do that. They don't mention that in here because they don't really teach you dynamic NAT with overload anymore. But I like to tell you about it because it's a way that's used in some networks. Our final method is pat, and it's even easier. IP NAT inside source list 1. So you still have to have your NAT ACL. So what is going to be allowed to be NATed? You do IP NAT inside source list 1, interface S011 overload. So this says take anything that matches this list and overload it to the public IP or IP address on 0001. And they call dynamic NAT with overload Pat with a pull overload. And that's what I just call it dynamic NAT with overload. Okay, so there's their example of it there. This is more common, however. It's much more common that we overload to a single interface IP address. Final item I want to mention before we call it a day is NAT 6-4. This has kind of gone the way of the dinosaur. There was, for many years, they were trying to figure out ways for IPv6 and IPv4 to coexist. And one of the things they talked about is doing NAT from 6 to 4 and 4 to 6. It's really kind of been, it's been put on the back burner. It's more now we should all be doing dual stack. It's really seen now that it's better to do dual stack. Don't do NAT 6-4. It is just not any longer something that they recommend. Okay. So NAT PT has been really depreciated, and they've replaced it with NAT 6-4. But honestly, again, most of the reading I've done is they're recommending you do dual stack until you can go full IPv6. Okay. Do we have any questions on anything we looked at today? Anything about ACLs? Anything about NAT? Notice how we just learned about ACLs, and we've already learned they can be used to control access to a V2I line. And then boom, the very next chapter, oh, look, we've got a NAT ACL. Now it's being used to determine what can be NATed and what cannot be NATed. So it's pretty amazing. And that's just the beginning of ACLs, because they are used for everything inside of the sun. Yeah, practice with ACLs. It takes a lot of work. It really does. It takes a while to get accustomed to them. It takes a while to get comfortable with them. But they're not too bad. You'll get used to them. And the more you work with them, the easier it is. The good news is they're very logical. You know, if you're good at logic, you won't have much trouble with them. Just be aware when you do the packet tracers, if it asks you to do something in the packet tracer, do exactly what it asks for. Otherwise, it's not going to give you credit for it when you do your packet tracer. So real quickly again, no class next week, everyone. You got 2 weeks till we get back together again, so keep working. Please do not forget to log in weekly to our class on canvas.stanley.edu. I need you to log in for me weekly so I can count you for attendance. Most of you are doing a really good job about that, and I thank you for it. But please log in weekly for that. If you do have any questions for me, email me and I will get back to you. And I'm going to stop the recording